Good morning.
Okay, hi, good morning, everyone. How was your day today? Hi.
Nice day.
Okay, there's only 63 of you. It should be 101. Where are the rest? Okay, I think I should start now. Okay, please hold on. Can you see the slide that I share you?
Can.
Okay, good. Okay, now we are in week week 10, right? So it's almost end of the semester. So we continue chapter 9, which is on center of gravity, center of mass, and centroid of a body. Oh, sorry, I should click the slideshow. Okay. So today's objective for 2 hours, you all should know what is the concept of center of gravity, center of mass, and the centroid. So you all should know how to find the location of this 3 point here, either center of gravity, center of mass, or the centroid. So there's a few activities here. There will be some reading quiz, and then we will look at the application, and then we will go into detail how to find the center of gravity, and then there's a few formulas that can be used to find the center of gravity, center of mass, and the centroid. So we will look at the example. There would be 1 and 2 example, and then there's a group problem solving, so you all should try on it so that I will see whether you know or understand what I'm teaching you. Okay, so let us start. Okay, doing Kahoot. So please log in the oh, sorry, I need to give you the numbers, right? Wait, hold on. Okay. Wait, hold on. Mm-hmm.
Kami Kahoot champion.
Miss,
Yeah,
is this just for fun or will be graded as mark?
just for fun.
Okay.
So don't worry.
Okay, thank you, Miss.
Yeah. Okay. Can you see the game pin?
Yeah, can
Yeah,
miss.
can.
Okay. This. Okay. There's only 49, but in class there's 77 of you. Okay, it took so long. Okay, can I start now? Okay, I think I should start now. Okay. Okay, ready? Reading quiz 9.1. Okay, what is the point defining the geometric center of an object? A, center of gravity. Not A, red color. The blue centroid, yellow, center of mass, and green, none of the above. So which one? Defining the geometric center of an object. I'm giving you 2 minutes, so you can answer it and read carefully all the questions. Oh, so long, 2 minutes. I think I should reduce it the time.
So long, I like.
Okay, what is the geometric center of an object? Okay, we will look at the answer later. 19 minutes and 90 seconds. Okay, the answer is centroid. See, what is the point that defining the geometric center of an object? So it'd be centroid. So there's only 2 questions. So this one, the last question. Okay, who spoke? Spock, not spoke. Okay, Jisoo, Easily, Ding, and Lisa. Yes, congratulations. Okay, final question. There is a motion of matter under the influence of forces. Okay, for example, dynamics. It is necessary to locate a point called what? Center of mass, centroid, center of gravity, or none of the above? Okay, which one? Motion that matter under the influence of forces. That point is called what? Center of mass, centroid, center of gravity, or none of these 3 here? Okay, another 10 seconds. Okay, the answer is center of mass. It is not a centroid. Okay, centroid, the one show you the geometry point at the center, not center of gravity, because we are looking for the motion that influenced by the forces. So it would be center of mass. So let us look who answered it fast. Okay, Kokos. Kokos number 3. And Jisoo number 2. Number 1. Where is it? Ding. Okay, congratulations to all of you who answered it correctly. Okay. Now let us continue. Our class, okay, is on chapter 9. Okay, hold on. I need to find it. Where is it? Okay. Okay, we have done Kahoot. Okay, we will look at the application. What are the applications that relate to what we're going to learn today? It's related to center of gravity, center of mass, and then the centroid. So what you can see here, it is a water tank. So this water tank have its own weight, right? And then we need to find the resultant forces that support this tank. So how we want to design this structure? Of course, you need to find the center point that can support this water tank. So how you want to find the center of the gravity, and then how you want to find the center of the mass of this tank. So we will go through in this topic. Another example or another application is such as this SUV. How can you make this SUV stable without tip over when you try to turn a sharp turn to the left or to the right? So how you want to make it a stable car? So you need to find the centroid point, and then you need to find the center of the mass. Of course, you have to find the center of gravity as well. And then another example, if you can see here, it is this goal, this football, American football goal, right? So how you want to design this structure to make it stable without falling? And then you need to find the center of the gravity so that it will stand stably. Okay. So you as an engineer, because you're taking engineering program in mechanical, so you need to know all the mechanical parts thing, okay, such as this one. When you work at maybe construction or a design company, so you need to design a structure like this one, goal, this triangle, right? Okay, now we will look at this concept of center of the gravity. So for example, this blue round, not so round body. Okay, in this body, there's a lot of particle inside of this body. So each of the particle inside this blue body here has its own weight. So each particle, this small particle, there's a lot inside of this. Okay, each particle will have its own weight. So label it as dW. So this body has a lot of particle. So you need to find the resultant weight, or the concept of the center of the gravity. So for this body, for example, this point here is the center of gravity. You can label it as G. Okay, so this show you the resultant weight of this structure, of this system, of this body. Okay, is it clear until now before I go further? All the description is here. Okay. Now we will look at the concept. Okay, have you all know this body have a center of gravity. So the location of this CG or the center of gravity, you can label it as S delta, S tilde, Y tilde, and Z tilde. So this is the location. Okay, this is the location of point. Okay, now you need to find. Sorry, this one. X tilde, Y tilde, and Z tilde is for the DW. DW that I showed you before, right? DW is the particle weight for each particle inside of it has its own weight. So you label it as DW. So the location of the DW is X tilde, Y tilde, and Z tilde. Now you want to find this G, the location of the G. How you want to find it? You have to use this formula: X bar, Y bar, and Z bar. So this is the location for center of gravity, which is G. Okay, the DW is you have to find the tilde XYZ. For G, X bar, Y bar, and Z bar. So this is the formula you need to memorize. If you want to find the X bar is equal to the integral of X tilde times dW over dW integral. Same goes to Y bar, so you have to use Y. For Z bar, you have to use Z tilde. Okay. Don't worry, we will look after this how to use this formula. But this formula is for center of gravity, okay? Don't forget this one if you want to find the location of the center of gravity. Now we will look at the center of mass. What is the difference between center of mass and center of gravity just now? Okay, center of gravity, you need to use weight. So for center of mass, you change it, the W with M, with mass. Or if the question asks you to find center of volume, so you can change the W with V. If the question asks you to find the center of area, so you can change the W with A, area. Or ask you to find center of length, so you need to change the W with L. So the main formula is, you can refer to the top one here. Okay, it depends on the question, whether you want to find the center of volume or center of area, center of length, you can change the W with B, A, or L. Okay, is it okay until now? Okay. Now let me continue to the centroid. Now we will look at this centroid. So I'm sure you all know centroid is the center of an object. For example, like this rectangular The center is at the middle C here. It's one triangular, so it would be 1/3 from height. Okay, you want to find the center. Then this one for a cylinder is another example I will show you. Okay. Okay, if the object is symmetry, the centroid would be on the axis. Okay, centroid will be on the axis. Okay, if in some cases the centroid may not be at the center. For example, at the bottom here, there's a quarter and semicircular. So the center is not at the centroid or lies on the axis. Like this one, it at the middle X and Y, right? In some cases, they're not. For example, like this. This is not at the on the axis. Same goes to semicircular and quarter. Semicircular and quarter. Okay. Now we will look at the step-by-step how to find the centroid of an area. This example. The question asks you to find the centroid of an area. So there's a 1, 2, 3, and 4 step. So first step, you need to choose appropriate differential element. So this one is you need to find the centroid of an area. So you have to use the dA. Okay, if the question asks you centroid of what? Centroid of volume. So you need to change it, differential element of volume. So it will be dV. Okay. So for area, the point must be X and Y. So for example, y equals to x squared plus 1. So this shows you an easy equation in terms of x. So you should use vertical rectangular. Okay, hold on. Let me, because I want to write something here. Okay, can you see the slide? Okay, the first step. For example, if the equation shows you an easy equation such like this one, yx. Hold on. I can't write anything. Okay, this one, for example, yx squared plus 1. So you need to use vertical rectangular. So you have to use vertical. Okay, if the it shows you easy to find or easy to find the center of area, so you have to use a vertical rectangular. So if it is difficult or because it's a combination shape that is not a uniform, so you have to use horizontal rectangular. So it would be horizontal rectangular. This one for easy, and then if it's a complicated shape, you have to use horizontal. Okay, step number 2, you need to express the differential element in terms of dx or dy. So which one? If you use vertical, it would be dx. If you use horizontal, it will be dy. Okay, step 2. Okay, step 3, you need to find the coordinates x tilde and y tilde of the centroid. So you need to find the centroid of this rectangular. The centroid of the rectangular in terms of the general point x and y. Okay, step number 4. You need to express all the variable and the integral limit in the formula using either x or y, depending on the differential element that you choose at the first step here. So either in terms of dx or dy. So this 4th step is similar to use for center of gravity or center of mass. So you can still use this 4th step. I think you all maybe not clear about this. So let us do example 1. It is example 1. You can see here is a curve shape y equals to x3. So you need this were given here x and y axis, and then the length 1 meter over 1 meter. Okay, you need to find the centroid location x bar and y bar. If you want to find the centroid, so you have to follow the step. So have you all remember the formula for centroid location x bar y bar? Let me show you back the equation. Okay, this one, x bar and y bar. Okay, the shape is only x and y axis, so you have to ignore z. So it would be x tilde dw is not a dw because you need to find the area, right? So it will be dA over dA, and then y bar equals to y tilde dA over integral of the dA. Okay, now let us look. Okay, so x bar would be equals to integral of x would be x, right? X tilde because it is in area, so it will be dA over the integral of dA. So from which point to which point? If you can see for x, you see x-axis, it would be 0 until 1. So it would be 0 until 1. And then same goes at the bottom here, 0 until 1. That's one for x. You need to find y bar. Okay, y bar, the formula is y tilde, and then the derivation of a element over dA. So you need to refer back for y. It is from point 0 until 1. So you write it 0 and 1, 0 and 1. So this is formula you should use. Okay, now you need to find the x tilde. You need to find the dA. So how you to find it? You have to follow the step that I show you previous, the 4th step. Okay, 1, 2, 3, and 4. So how can you find the centroid when the shape is like this? It is difficult, right? How to find? So you need to follow the 4th step. Okay, first step is you need to choose an appropriate differential element. So you need to choose either vertical or horizontal. So if you can see, this equation is simple equation, right? Y equals to x power of 3. So if it is simple, so you can use vertical. So you need to use vertical rectangular. Okay, how you want to use this vertical rectangular? How you want to use it? We just have to draw a rectangle at this graph. Okay. Make sure it locates, let me draw it properly. Okay, make sure it reach the curve. Okay. Okay, now you have done step 1. You have done. Just draw the rectangular, either vertical or horizontal. Now step 2, you need to express the dA in terms of the differential element dx. So I've told you before, right? If it is in vertical, it would be dx. So for horizontal, it would be dy. Horizontal would be dy. Okay, now you need to express it. So step 2, it would be dA equals to what dx. So you just fill in this equation, y equals to x power 3. So it would be y here. So if you change this y into x, it would be x power of 3. So x power of 3 dx. So dA equals to x power of 3 dx. Okay, you have done step 2. So you have done step 2. Step 3, you need to find the coordinates of x, x tilde and y tilde. Oh, the tilde is run away. It would be x tilde and y tilde. Okay, so you need to find the coordinate of x tilde and y tilde. What is the x tilde and y tilde? What is it? If you remember, I'll show you what is x tilde and y tilde. Y tilde. You can see here, x tilde and y tilde is the center of the DW for each particle. Okay, each particle, the center point is x tilde, y tilde, and z tilde. So in our situation, the question is, you need to find the x tilde and y tilde. So where is it? Where is the x tilde and y tilde? Okay, no one answered it. So it would be at the center of this rectangle. So it is center of this rectangular. So you need to find the x tilde and y tilde. So it would be until this point. So this one until here is the x tilde, and then from this top here center until this one is the y tilde. So you need to find. How you want to find it? So step 3. So you need to find the x tilde. It is unknown, right? So x tilde, you must find it in terms of general point x and y. So for x tilde, you can label it as x. Okay, because we want to write it in terms of x and y only. So not other symbol. So you can label it x tilde equals to x. And then how about y tilde? How about y tilde? So for y tilde, this rectangular, the whole height of this, it is y. Okay, for this whole, it's from top until down, it is equals to y. So if you want to find the middle of this rectangular, it will be half of the y. So it would be y half. Okay, so you need to change this equation to x because the integration is based on x. So you have to replace the y. How you want to find it is from the curve equation, which is y equals to x power 3. So it would be x power of 3 over 2. Okay, now you have the x tilde and y tilde based on x. Okay, this one also dA is based on x. Okay, you have done step 3. So now you need to use all these variables, all using the integral formula, which is because you want to find the x bar, right? X bar equals to the integration of x tilde over dA and over the dA, right? So now you can replace inside the one x tilde is x, and then the dA you have to use the same symbol x, so it will be x power of 3 dx. Oh, don't forget the integral, and then dA x power 3 dx. Okay, don't forget it is from 0 until 1. 0 until 1. So you can solve this equation. I don't have to show you how to integrate. Right, you all must know how to find this one. So it would be x4. So when you do the integration, it will be x5 over 5. So it will be x5 over 5. Okay, over this one, it will be x4 over 4. So when you arrange x4, I don't have much space here. So it's x4 over 4. Don't forget it is from 0 to 1. 0 to 1. Same goes to at the bottom here. 0 to 1. So when you solve it, you change the x to 1. So you will get 1.1 over 5 divided with 1 over 4. Right. So you will get 0.8 meter. The unit is in meter. Don't forget. Unit give locate 1 marks. So you have done. You have find the x bar. Okay, how about the y bar? Okay, y bar is equals to the integral of y tilde times dA over the integral of dA. So you can replace it. So for y, this one y tilde is x power 3 over 2, x power 3 over 2, and then the dA is x power 3 dx, x power 3 dx. Okay, don't forget the integration of 0 until 1. So 0 until 1. The dA is x power 3 dx. So you can solve this equation here until here, and then you will get at the end is 1 over 14 over 1 over 4. So you will get around 0.28. Okay, 0.28 meter. So you have done step 4. So now you know the location, the exact location for centroid. So 0.8. So it would be around not until 1 meter. So it would be 0.8 and 0.28. the centroid. So now you know the location of the centroid point. Okay, I've shared with you the step-by-step how to solve this question on the next slide. So until now, is it clear?
Clear.
Okay, I've shared you the step-by-step. This one, how to solve. Okay, you can see the x tilde and y tilde is the centroid of the rectangle. Okay. Example 1. So now we will look at the example 2. How you want to find it? This one is not okay. Given here the shape and associated horizontal rectangular strip down. Oh, so it was given. The shape is a quarter circular, and then it give you horizontal rectangle. So you have to use it. And then this curve is equal to y square equals to x. It is the size 1 meter x for x and y 1 meter. So you need to find the DA, so it will be the center of area. And then you need to find the center of the horizontal x tilde and y tilde. So you have to follow the step. There are 4 steps I showed you before, right? 4 step, which is okay. First, you need to use horizontal or vertical, but the question already give you have to use the horizontal. So step 1 is already done. So you need to express the area is depend on what element, x or y. If horizontal, it would be dy. So it would be dA equals to what? dy. Okay, and then you need to find the coordinate center of the coordinate. So it'd be like this. Okay, this one is step 2. You have to make sure the derivative element area is referred to dy or dx. Because we're using horizontal, it would be dy. Okay. So dA equals to what? dy. So it would be opposite of it would be x. So for x, you have to replace that in a same element or same symbol. So for x is equal to y square. So you can use y square equal to dy. So now this one is step 2. Step 3, you need to find the centroid. Okay, the center point of this horizontal rectangular. So it would be from 0 until the center is x tilde, and then the y is from the axis until the point, the center point of the rectangular will be y tilde. So how you need to find it is, for example, for x, if you can see here, the whole this one, the whole, if you want to find it, the 1 minus x. Okay, now 1 minus x, you will get the length of this rectangle. So how you want to find the center? You have to minus divide by 2. So that's why x plus 1 minus x over 2. So at the end, you will get 1 plus x over 2. So you replace the x with y, because the first thing you choose is dy, because it is in a horizontal. So dy. So all must be in y. So that previous example, it based on element dx, right? So all must be, make sure you change it. Must be the integration must be in x. Okay, so for y, make sure all you have to change it to y. So for x is equal to y square. You replace it. 1 plus y squared over 2. So for y, is just directly through from the axis, so it will be y bar. Because it is there's no different shape or length value below this y bar, so just directly. So now you know the y bar and the x bar, so you can do the next step. So can anyone try to solve this one? Oh, it's okay. I think you all can do it, right? You can do the integration like the one. This one you need to find the x bar and y bar. Oh, sorry. The question asks you to find dA and x tilde and y tilde only. So this question did not ask you to find the centroid. So you don't have. So the solution is until here. So don't worry. So you don't have to solve this. Okay, now we will look at the concept. Before I go to the next slide, is it okay? Did you all understand? Hello everyone. Is it okay until now? Is there any question?
Madam, I don't understand the step 2, the expert.
The X, this one, right? Did you mean this one?
Yes,
What?
madam.
Okay. X plus 1 minus x half, right? So if you can see you okay, you look at this first. 1 minus x, it would be 1 minus x. So it would be the length, this rectangular length, right? You need to find the centroid. So it divide with 2. So you will get only until here. So you need to plus x. So you just get the value. This one is only half of the rectangle. But you need to plus x because it must be from the origin until the center value.
Oh, okay, I get it, madam.
Okay.
Thank you, madam.
Yeah. Okay, so is there any question? Okay, now we will look at the concept quiz. Okay, question number 1. The steel plate. So this is a steel plate with known weight. So there's a weight value, but the thickness is not uniform. So the thickness is different. And same goes to the density. So of the 3 parameters, which is CG, center of gravity, center of mass, and the centroid, which one is needed for determining the support reaction? Okay, which one that can support the reaction? The clue here, the weight and the thickness is not uniform. So if it is not uniform, it refers to what? Which one is a support the reaction? Center of gravity or the centroid? Okay, which one? Okay, let me show you back the notes that mentioned here. Okay, which one? Okay, which one? Okay. Communication, messenger. Okay. Okay, this one. the centroid or the center of gravity is homogeneous, so it will be constant. Okay, if it is homogeneous, the centroid or the center of gravity must be constant. So it is at the same point for centroid and the CG must be at the same point if the body is homogeneous. If it is in a same density, same weight, so the point must be same. So in our case, it is non-uniform. So which one? Defining the support, this structure. So it would be not centroid. Okay, because it is non-homogeneous, so it won't be the centroid. So it will be center of gravity. So next is, are all three parameters located at the same point? Of course, no. I've shown you the point before, right? If homogeneous, it would be yes. The point is at the same. But if not, it would be no. So the answer would be B. Okay, question number 2. When determining the centroid of the area above, which type of differential area element requires the least computational work? So which one? Which type of differential area? Is it vertical or horizontal or polar? Polar. Or none of the above. Which type shows least computational work? Try to think on it. Can anyone give me an answer? A is vertical. Why is it vertical? Why is it okay? Someone said vertical. Why is it vertical? And there's a few said horizontal. Why? Okay, yes, it is in Y already, because if you can see here, if you use vertical, you have to do it twice. It is complicated. So then you need to use vertical. So it is combination of two throws, okay, directly. Because you want to find the least computational work. So the answer is vertical. Okay, now we are going to do the active learning. So I will give you 10 minutes. Try to solve this question. So I will get back to you at 11:15. Okay, the question is, this is a steel plate. The thickness is 0.3 meter thick. And then the density is 7,850 kilogram per meter cube. So you need to find center of mass. So it will be dm, center of mass. Also compute the reaction at A and B. So this one, number 1, and then number 2, you need to find the reaction at A and B. So you need to find the reaction at A and B. So there's two things. So first, you need to follow the solution step to find the CM. So there's a 4 step. Okay. This one for question number 1. And this one for number 2. You need to use the 2D equation of equilibrium. So you need to use the equation of Fx equals to 0, and then the summation of y equals to 0, and then the summation of the moment equals to 0. Okay, on the equation of equilibrium, because you want to find the reaction at A and B. So I will give you 10 minutes. Try to do it. You can discuss with your friend. Okay, I get back to you at 11:15. Okay, hi everyone. Have you all done? Okay, have you all find the x bar and y bar? What's the value for x bar and y bar? This one you need to find. This one you need to find the x bar and y bar. What is the value for x bar and y bar? Hello everyone. What is the value for x bar and y bar? Okay, that's okay. For x, kx is 1.26. Yeah, correct. And then for y bar is 0.143 meter. Yeah, correct. So how about second part? You need to find the reaction at point A and point B. So you need to find the reaction. So you need to find the AX. You need to find the AY for at point A. And then how about B? What is the reaction at B? So for B, there's only one force because it is in roller. So it would be at this direction. So it would be NB. Have you all remember? This one. For roller, there's only one direction. So it would be NB. If it is in a pin like this, at point A here, there would be AX and AY. So there's a two direction. It would be AX and AY. Have you all remember? Maybe this one is in chapter 4. Okay, if the shape or the structure there's a pin, there's a two forces that react at this pin. It would be AX and AY. If it is in roller, there would be NB. So you need to find the reaction at A would be AX and AY. Then for B would be NB. This is the second part after you find the X bar and Y bar. So what is the value for AX? What did you get for AX? How you want to find the AX and AY? You have to based on the equation of equilibrium. So you have to sum all the forces at X axis and then sum at Y and then the summation of a moment. All of this would be 0. So which point you want to choose so that it is easier to find the AX unknown, AY unknown, and then the NB. So how are you going to find it? Okay, let me show you. Because there's no one answer. Okay, let me show you. Okay, this is the shape of the plate, steel plate. Okay, you have to choose. There are 4 steps, right? The first step, you need to choose either vertical or horizontal. In this situation, you can choose vertical is easier compared to vertical. So vertical, you have to use 2, and then you need to find it is difficult to find it. So it is easier to use vertical because it is combination of the first part and the second part, because it is different. Y square equals to 2x, and the bottom is y equal to negative x. So if you use vertical, it must be in dx. Okay, first step. If you use vertical, so it will be dx. And then in this question is based on center of area. So it will be dA. Second step, dA equals to what is it? Y2 minus Y1. So which one is Y2? Okay, on top here is Y2 and label as 2 and 1. So you need to minus Y2 minus Y1 over dx. This is what is okay for Y2. Y2 is you arrange back this equation, so you will get 2x third. So 2x third, and then for Y1 at the bottom here, you change it. It will be negativity will be plus. So set to x plus x over dx. So this one is step 2. Step 3, you need to find the center of this vertical rectangular. So at this point until center here is dx and tilde. So x tilde is also equals to x because there's no change of maybe there's no form that you need to minus or anything. Okay, so just write it as x. So then y bar, how you want to find this y bar? Must be the summation top and bottom divided with 2. So top is 2x, and then minus you have to plus, right? So plus there will be minus x over 2. I think this one silap ni. It would be 1 actually. 1 and 2. So this one it would be 1. 1 is 2. Okay. Okay, now okay. Step 4. You just fill in back. Use the formula if you want to find the centroid. So x bar equals to x tilde dA. So you just fill in back what is the x bar value. Okay, x tilde is x. dA is set to x plus x over dA set to x plus x, and then you integrate it, and finally you will get 1.257. So same goes to y bar. You just use the formula, fill in the value, the equation that you get from the previous one, the previous y tilde. Okay, and then you will get 0.143 meter. So now you know the location center of mass. Yes, it is 1.26 meter and then 0.143 meter. So now part 2, you need to compute the reaction at point A and point B. If you can see, okay, part 1 you have done. This one also you have done. So now you want to find the reaction at point A and point B. Let me show you. Okay, now, okay, before you want to go further, okay, you need to find the force, right? The force of the plate. So what is the force or the weight of this plate? Because this must be W, right? So this one is equals to FD. Moment is, have you all remember the equation for moment? Moment is equal to FD, right? Moment equals to force times the distance. Okay, so for this plate, you need to find the weight of this plate. How you want to find the weight of this plate? You need to use the formula, which is F equals to mg, right? Or you can use F equals to rho GV. In this question, they did not give you the mass. They only give you what? Question. Only give you density. Okay. So you have to use this one at the bottom here. F equals to rho GV. So you know the density is 7850, and then you know the gravity. So you need to find the volume. How you want to find the volume? Volume can be area times length, maybe, right? Or thickness. How you want to the question give you thickness value. Okay, let me see. Yeah, 0.3 meter thick. So now, how about the area? You know rho, you know G. You need to find the V. You know T. V is up here. So now, how you want to find the area? Where did you get the area value? It is from the previous this one, the previous equation here, dA. dA is the area, so you will get the area value 4.667. Same goal, it is the same dA, 4.67. So now you know the A. So you just fill in. The density is 7850, 1.8 is the G, and then this is the volume. So now you know the W. So you know the weight of this steel plate. So why you need to find the W? Because in this equilibrium equation, that's the weight that you need to add on. Right. Okay, now let us do the summation of fx equals to 0. Okay, the direction on the go through the right side will be positive. So how many force here? There would be for axis. So there would be ax, right? There would be ax, and then what else? This one is y. So another one is nb. So there's only 2 for x-axis. So ax, the direction is to the left. So it will be negative. And then this one for nb. This should be nb. nb sine 45. Okay. In this slide, it shows you the nb first, the value for nb, because you find the nb first. So now let us do the the summation of the moment. Okay, the summation of a moment is equals to 0. So if you assume the direction downwards is positive. So which point you want to choose? A or B? Which one is easier? If you want to find the unknown force. A or B? You must know the concept. Okay, yeah, correct. A. Why? Because at A, there's too many force unknown. So you want to reduce it. So it is better to choose A. Because the only unknown is NB. So that you can find the NB. So you have to choose the A. So the summation at point A is equal to 0. So for moment, there's only two forces here. So NB, if you move upwards, is it positive or negative? Okay, it is positive. Why? Because you assume at the first place, counter clockwise is positive. So this one NB is positive, and then the range is 2 third 2. Okay, how we want to find? It is because of this one 2. Third 2 is the one you find just now. Where is it? I think, where is it? Just now 2 third 2. 2. Where is it? Okay, it is based on the trigonal. Okay, 2 third 2 is trigonal. Okay, and then this one is the weight W. The value is 107.8. It will move clockwise, so it will be negative. So negative 107.8, and then the distance is 1.26. So you can solve this equation so that you can get NB. So NB is 47.9. So then you replace it below here. So now the unknown is just AX. So AX, you can get the you can solve it. So it will be 33.9 kilonewton. Okay, so you have done at for moment and Fx. Now you can find the AY. So Fy is equal to 0 if you assume upwards is positive at point. Okay, which point? Because you want to find the AY. So you have to sum all the forces. So it would be NB here, NB cos 45 because in Y, and then AY upward positive, this one negative. So you can solve this. AY plus 47.92 cos 45 degree minus 107.8. So you will get AY is 73.9 kilonewton. So this is how you solve this question. Okay, is it clear until now? Is it okay? Okay, good. Okay, now let us do the attention quiz. If a vertical rectangular, okay, this is a vertical rectangular, is chosen as the differential element, then all the variable, including the integral limit, should be in terms of what? Okay. This one I showed you before. What is the answer? Vertical rectangular. Okay, so what element? X, Y, Z, or none of the above? Okay, yes, correct. It is X. Okay, let me show back the point where Okay, this one. For vertical x element. Okay, so the answer is A. Okay, number 2. If a vertical rectangular strip is chosen, then what are the values of x tilde and y tilde? Okay, in this situation, if no. Okay, if the vertical is chosen, this one, if the vertical chosen. So what are the value for x tilde and y tilde? X tilde and y tilde is the center point of this rectangle. Okay, correct. The answer is D. D is x and y half. How is it? So from this point here until this one vertical, this one is x tilde. X tilde, there's no any shape that that can change the center. So x tilde is equal to x. Okay, correct. And then how about y? Okay, for y you need to have I'm sorry. Vertical. I'm mistaken. Correct. Delete. I want to delete this one. Sorry. This one vertical. Center point here. So at this point until here is x tilde. So because there's no form or shape that can change the center, so name it as x. So for y, it is half of this whole rectangle. So this one is y tilde. So it is equals to y minus half of the y. So half of the y. Okay, so it would be D. Okay, so we have done the first part of this chapter 9. So we have another 10 minutes. Yeah, it depends on the shape or the vertical or horizontal. Okay, now we have time. We have another 10 minutes. Let me continue chapter 9, part 2. Where is it? Chapter 9, part 2. This is not the one. Wait, hold on. Why is it not come up? Okay, please hold on. Okay, can you see the slide? Can you see the slide? I think I share the screen. Okay. Okay, good. Okay, now we're still in chapter 9. This one part 2 is on composite body. Okay, you need to find the location of the center of gravity. Okay, same goes, you need to find the center of mass, and then you need to locate the centroid. However, in this part 2 is on the composite body. Okay, first part, on the first part, I'm just showing you a single body, single shape. Now, if the shape is composite, for example, there's a lot of shape, right? Square and triangle, or maybe like this one. There's a on top of it, a triangle, and then rectangle, and then this one semicircular. So how we want to find the center of the gravity, center of the mass, and the centroid? Okay. Do we have time to do Kahoot? I don't think so. We have only 5 minutes, so let me just continue. Okay, what are the application? Okay, for example, like this composite shape or composite body, it is in the I-beam and the T-beam. Why I call it composite? Because this one rectangle is different size. Same goes this rectangle different size, and on top here same at the bottom. So it is we can say that this shape is in a composite shape. Same goes to this T-beam. Bottom on top and at the bottom here the size is different. So you need to find the centroid. If the shape is like this, how you want to find the centroid point? And then how you want to find the center of the mass? How you want to find the center of the gravity? So now we look at for example, in this real situation, engineering parts, the compressor. You can see here, number 1, this one is the instrument panel. 2 is the filter system. Number 3 is the piping. Here's one for the liquid tank. This all equipment is on top of the stage. So this stage, there's a support structure at point A and B. These all are heavy parts, equipment, support by the A and B. How you want to find the center of the gravity in the system, in the structure? How you want to find the centroid? So this can be known as a composite body because there's a lot of shape and then different weight. So you want to locate the centroid, and then you need to find the center of the gravity, center of the mass. So how you want to find it? Okay. For example, another example, there's a lot of there's a 3 particle here. The shape is different, and then the weight is different. So how you want to find the center of the gravity? The center of gravity must be the resultant from the all weight, right? From the all particle weight. So the center of gravity is outside. It is not at the middle of each particle. It is outside of these 3 particles. So the gravity is outside here at point G here. So you need to locate the point G. Where is it? So the label as X bar, Y bar, and Z bar, same like first slide that I shared to you, right? But you need to change at the end. It's not a DW, label as W because this show you W. The first slide, I name it as a DW. So it is the same thing, but just the label is different. So it's a summation of the x integral times w over the summation of w. Same goes to y bar and z bar. So if the question asks on the center of mass, you can change this w with m because it refers to mass. W refers to weight. Okay, same like the first slide I show you, right? Okay, now another example before we end. I think we have another 2 minutes, so it's okay. I can continue it. Okay, for example, this body. Okay, there's a different shape. Okay, there's a hemisphere or semicircular, and then there's a square, and then there's a triangle, and then there's a circle hole here. So it is called a composite body. So it is made of simple shaped parts. Okay, and then another one. You can see here there's a triangle, 1 and 2, and then there's a square, not square, small rectangle, and then the thin rectangle, right? 2 thin rectangle, then 2 square, 2 triangle. So this is a composite body because the different simple shaped parts in one structure. So you need to find the center. So if the shape is like this, how you want to find the center? If the shape is just a circle, you know the center is at the center of the circle. But how about if the structure is in this different kind of shape? So where you want to find the centroid? Maybe it would be outside of this structure or at below here or the top here. We don't know. So you have to find the centroid, and then you have to find the CG, center of the gravity. Oops. Okay. So for the second part, what I will going to show you how to find the center of the gravity. It is much simple than the first section or the first part that I showed you before. You have to use the formula, and then you have to do the integration, right? So this part is much simple than the first part that I showed you before. So I will show you there's a few steps. So there's a 4 step here. Okay, first step, you need to divide the body into pieces that you know in shape. Okay, like the one I show you, right? You need to divide the body into pieces. Okay, for example, in this structure, you need to divide it. Okay, this A part is semicircle. This B is square. So you need to divide. This part is A, square B, triangle C, and then this whole circle is D. It is first step. So for whole, you need to write it as a negative. Okay, you need to write it as a negative size. So so the shape just now is like this, right? Semicircle, and then square, and then triangle, and then there's a hole here. So you label it as semicircle plus square plus triangle minus hole. Okay, don't forget because the circle is whole, so it will be minus. Okay. Step 2, make a table with the first column for segment number, the second column for weight, mass or size, And then the next column is for moment arm. So next step, this one first step. Okay, second step, you should make a table. Okay, make a table. So first column is for the segment number. So you can write it as A, B, C, D, like this one. You name it A, B, C, and D. So you label it as A, B, C, D. And then the next one, you can write it whether it is based on weight or mass or area. So you need to find each part, the area, or each part of this is the weight, their weight, and then the mass. Okay, you can write down the second column, and so on, based on the what question one. If they want to find the coordinate, you have to find the. I will show you later. Okay, don't worry. Okay, third step. Fix the coordinate axis. Determine the coordinate of the center of gravity of centroid of each piece and then fill in the table. So you need to find the coordinates. The third step, you need to find the coordinates for each shape here. So you need to find this x in x tilde y tilde for this shape, and then for square you need to find the x tilde y tilde for this square, and then this triangle you need to find the x tilde and then y tilde of this triangle, and then this hole you need to find the x tilde and y tilde. What is the x tilde and y tilde? It is the center point for each this shape. So you need to find, this is step 3. Okay, step 4, sum the column to get x, y, and z bar. So this column, there's a x tilde, y tilde. So step 4, you need to find the summation. So you have to find the summation at this bottom, one summation. Then for x tilde and y tilde as well. So if you get the summation, then you can use to find the x bar. This is the final one. So don't worry, I will show. Oh, we have only. You have other class after this, right? Hello, you have class after this, right? Okay. Let me just show you the example. Okay, example. There's a 3 block here, A, B, and C. So first step, you need to divide into the body piece, right? You label it as A, B, and C. Triangle, this is one rectangle and triangle. So the second step, you need to make a table. Okay, before that, it is based on a center of volume. So it will be based on volume. Okay, and then you have to follow step. Okay, after you divide this part, the first step, second step, you need to do the table. So like this. Okay, first part segment A, second part B, third part C. So this question is based on volume. So the second column, you have to write based on volume. Don't forget the unit, meter cube. And then you need to find each part here for triangle. What is the volume for triangle? It's length times height times thick. So 0.5 times 1 times 2, 1 times 1.5. And then how about the height? Height is 1.8. And then the thickness 0.5. So when you divide, you want to find the volume for A, you will get 0.675. So you place it back at this column. Same goes to B and C. You need to find the volume for this rectangle. For B is 2.5. Okay, the length is 2.5 from here until here, time the height, that is 1.8, and then the thickness is 0.5. So you get 2.25 meter cube. So to 2.25, you just fill in back in the column. Same goes to C. You have to find the volume. For C is 1.5 times thickness 0.5 times 1.8. Because it is a triangle, so you'll be half of the square. So 0.5 times the volume. So you will get 6.675. So now you know the volume. So you need to find the centroid for each shape here. So for x tilde, the centroid is half over 3 of the height. If you remember, if you want to find this triangle, centroid is 1 over 3 height. So 1 over 3 height is 1 over 3 times 1.8. So it would be what? 0.6. Am I right? So that's why the Z is 0.6. Okay. And then how about Y? Y would be half of the 0.5 is 0.25. Okay, it is 0.5 half. Then you will get 0.25. And how about the X? Okay, X is the length is 2, half of the 2. So half 2 is 1. Okay, half 2 is 1. Okay, now you know the center for A. Now you need to find the center of the B. Okay, for X is 0.5. So half of 0.5 is 0.25. Then for Y is 2.5. 2.5, half of the 2.5 is 1.25. Then how about Z? Half of 1.8, so you will get 0.9. So how about C? C, the centroid for X is half of the 0.5, so it will be 0.25. And then at Y, how to find? It is from the origin. So along this one is 2.5, 1.5 will be 6. So half of this 6, so it will be 3. Okay, it must be from the origin until the point here, so it will be 3. So how about Z is half over 3, so 0.6. So now you need to find the x tilde times v, y tilde times v, z tilde times v. So you just divide this one times, and then you will get this value. So step 4, we need to do the summation of the column. So for volume, you have to do the summation, and then for x, and then for y, and then for z. So now you know the value of volume xv, yv tilde v, z tilde v. So you find the what x bar, y bar, and z bar. So from this equation, you just fill in back. This is the formula to find the x bar, y bar, and z bar. So it is much easier compared to the first part, right? First part you need to do the integration. There's an integral, right? So now just fill in back, then you will get x bar is 0.391, y bar 1.39, and z is 0.788. So now you know where the center of the volume for this structure. Where is it? For x is 0.3, so around here 0.3, and then for y is 1 point something. Okay, so it will be at this point, and then the z 0.7, so the center point would be at this. Okay, based on this value, we will get the point is center of volume is at here, around here. Okay, now it's already 12 o'clock, so I will end the class now. So next week would be your exam 2 on Wednesday at the same time, 10 until 12. So for I will do a replacement class next week. I will inform you in Ulearn. Okay, is it okay now? You have class after this, right? Don't forget to record your attendance. Okay, see you next week.
Bye-bye.
Okay, bye.
Thank you.
Yeah, thank you. Bye-bye.
Thank you, madam.
You're welcome.
you